Hello, everyone, and welcome to today's SANS webcast. Getting started with the SIFT Workstation. My name is Carol Auth of the SANS Institute, and I will be moderating today's webcast. Today's featured speaker is Rob Lee, the Curriculum Lead and Author for Digital Forensic and Incident Response at the SANS Institute. If during the webcast you have any questions for Rob, please enter them into the questions window located on the GoToWebinar interface at any time. Please note that this webcast is being recorded, and a copy of the slides and recording of this webcast will be available for viewing later today and can be found on the SANS registration page. And with that, I'd like to hand the webcast over to Rob.
Hi, everyone. Hope you're having a great Veterans Day. Thanks to all the veterans who served. I really appreciate all the efforts that everyone in the DoD and everyone makes sacrifices around the world continually. Having said that, today we're going to be talking about the SIFT Workstation, which we have a lot of really cool announcements that we're going to be making today officially, and wanted to touch base on some of the new and wonderful things that we're currently doing with the SIFT Workstation. My name is Rob Lee. I've been teaching for SANS since the year 2000 now. It was my first time I ever did an at-night for SANS, but I'm a former DoD, worked in the United States Air Force, and worked in the Air Force Office of Special Investigations, worked at government stuff after I left the service, and then ended up going over to Mandiant, and finally have my own company, Harbingers LLC, which is where I'm currently based out of Boston, Massachusetts. I do incident response, digital forensics, and threat hunting consulting around the world. So it's my pleasure to talk to you about the latest iterations of what we currently have with the SIFT Workstation, and to introduce it to you for a lot of folks who have never seen it before. So without further ado, I'm going to go ahead and dive into my screen stuff. So this presentation is really a how do you get started with the SIFT Workstation. Now, one of the things I'm really glad to actually show for the first time publicly is our brand new SIFT Workstation logo that you could see there. We spent some time figuring that out over the past 2 to 3 months, and of course everyone on the team seems to like that the best. Kind of going through a maze and using a SIFT Workstation to do targeted extractions, kind of the framework there. For those of you looking for where you could download the SIFT Workstation from, there is a quick link here. But the SIFT Workstation is really an open source forensics framework that basically allows you to install it on your own workstations, your desktops. You can also download it as a appliance, so you could work with it in a virtual environment as well. And we're going to show you the various methods of how you to potentially download and work overall with the SIFT Workstation. But the main idea behind the SIFT Workstation is that there's so many free and wonderful open source utilities that hundreds and hundreds of open source authors have created over the years. And one of the things that we've always found is that it's really difficult for someone to manually try to configure their systems to try and get all these different capabilities working together. So in the aspect of how Security Onion and Kali and other frameworks accomplish a very similar vein, what we're trying to do with the SIFT Workstation in particular is to set up a framework that you can install directly on any Ubuntu 16.04 system through a simple installation script that will automatically download and install all the requisite packages and tools that are necessary in order to get basic functionality of the capabilities for the SIFT Workstation. So a lot of the free tools and open capabilities that are currently out there are going to find a way into this framework. And of course, we're always looking for additional suggestions of things we could add in here as tools, as long as they don't conflict with one another. But even if they do, with the capability that the latest Docker support into the SIFT Workstation, we could always launch something with a Docker instead of having to worry about the dependencies overall. So the idea of the SIFT Workstation is really trying to aim to create a singular capability that incorporates all these wonderful tools that are out there. So when you end up looking at it from a comparable aspect, when you're looking at Encase or FTK or other tool sets, you're able to potentially meet, if not greatly exceed, the capabilities of a lot of the commercial utilities that are out there in order to accomplish digital forensics on your own. And so the SIFT Workstation, as a result, has found its way into Fortune 50 companies as one of their primary tool sets. It's found its way into DoD and military weapon systems around the world, where they would install this package and automatically configure their systems to be able to use the tools that are found in there. But basically, we wanted to be able to use these. And the other thing, too, we also have SIFT and RIMNIX, which I'd like to give a nod to Lenny Zeltzer's RIMNIX, but you could actually have both SIFT and RIMNIX sitting on the same platform and integrated together. So you could actually do malware analysis, incident response, forensics, all on a single platform if you wanted to do that. So why did we ever get going with the SIFT Workstation? And as I mentioned before and alluded to, is that when you start installing capability on Linux systems, that trying to get all the dependencies and libraries and everything synced up is actually quite a chore, where many examiners out there just want to take a system and use it immediately for being able to accomplish forensics. So our first couple of distributions of this were actually found only in a virtual machine that we only used in DFIR classes starting around 10 years ago in 2007. Then we started to release that virtual machine in an online distro in about 2010. And 3 years ago, we moved to a PPA repository for easy updates. That way, we don't have to actually have a static build that we're going to release at the SIFT Workstation. You don't really put a version on it because it's made up of hundreds of open source tools and utilities. So when you do an update, it's going to update to the latest version of those utilities that are loaded in our PPA repository or were pointed to by our PPA repository. So if you're using something like Redripper or volatility or recall, that as soon as you do the update or the installation, it would automatically download the latest versions of those capabilities. So that really doesn't make the SIFT Workstation versionable. It basically makes the SIFT Workstation a package manager that helps incorporate the majority of these tool sets so they function properly without a lot of configuration on the user's part. Starting this year, my DevOps team lead, Eric Christensen, he's been working on shifting over from a simple bootstrapped shell installer, which has a lot of security risks, over to a salt stack installation process. And through the salt stack, if you're not really familiar with it, it allows for a lot more flexibility and configurations when something is actually going to go through an official install. So at this point, we actually have an installer that you're able to use and download, install on an Ubuntu 16.04 system, and basically, as you see here on the screen, just type sudo sift install, and it will then magically install all the packages for you. And then that same installer sift can also be used to do upgrades and to do version changes and more. So whenever you wanted to do an update, you would be able to just use sudo sift update, and it'll automatically update to the latest SIFT Workstation versions of all the tools that are built inside of it. And we'll give you some of these demos as we're going forward here. So where do you get the SIFT Workstation from? How do you work with it? So at this point, we end up having two different installation options available to you. The first is probably the easiest if you're just getting started, is that we have the SIFT Workstation in a simple file. It's an OVA format that you basically can use with VirtualBox, any of the virtualization products. It is open virtualization standard. So the OVA itself is going to be a basic Ubuntu 16.04 system with the SIFT package set that's installed on it. Very simple, but even in the end of it is still about 4 GB download when push comes to shove. And so as a result of that, when you end up taking a look at that and doing that download and just opening up within your virtual hard software, VirtualBox or VMware or whatnot, it'll automatically load in and convert it into a virtual workstation, which will give you some demos. Now, for those of you who are looking at trying to install the SIFT Workstation on a standalone desktop system or your own platforms, you don't have to dedicate your own VM for this. You could actually dedicate your own desktop, laptop to be a SIFT workstation. So the first thing you basically need to do is download and install Ubuntu 16.04 on any system, and that could be anywhere. And then if you follow the steps here, you basically download the SIFT command line interface, the CLI, using the install instructions found on the link that I mentioned earlier. And you basically click there, basically say, here's how you download it, here's how you verify the package, here's how you install it on the SIFT. And once you do that, you basically run the command sudo SIFT install, and it will install the latest version of all the tools of the SIFT Workstation onto that platform, and you're good to go. And that's where you could also install Security Onion and Remnix and a bunch of other things that are anything that is 1604 compatible at that point. Now, as I mentioned before, the SIFT Workstation, you could download the OVA file directly from the SANS website. Once you log in, you'll have to have a portal account to get access to this. You'll be presented with two downloads, the MD5 of the SIFT OVA file and, of course, the OVA file itself. You simply download it, and then once you have it downloaded, you double-click on it within VMware, any of your products, and it will automatically bring up a window like this one to import the virtual machine, and it will allow you to import the virtual machine as it's your own VM. And then, we'll talk about what do you do with it at that point. Once it's installed, how do you get started with it? It's kind of the main point of this conversation. The other thing that not a lot of people know, but with the Windows 10 Creators Edition, it actually comes with an optional Ubuntu 1604 subsystem. So as a result of that, what you could do is you could enable that subsystem on Windows and then subsequently install the Ubuntu operating system on the back end of Windows. So all that functionality you have with Ubuntu, you can now have it sit in the same location with the SIFT Workstation by downloading Ubuntu and then installing the SIFT Workstation. So what you're seeing here is the initial PowerShell script that you need to run to enable the Windows optional feature. You can also do this via the GUI, the programs and features. You would actually enable the Windows subsystem Linux, and then you go out to the Windows App Store or Microsoft Store, and you simply do a search for Ubuntu, and you'll see an Ubuntu package show up, and you simply install that. And once it's installed, it's going to go through the kind of installation process that you see here. It's going to ask you for a new Unix username. In this case, we put in SANS Forensics. We put in a password as Forensics. And at that point, we basically will have a successfully installed 1604 subsystem on Windows. Once you're there, you follow the same process like you're doing a dedicated install on your desktop systems on an Ubuntu system, and you basically download the SIFT CLI tool, and we move it into a user local bin SIFT directory. We change the permissions on it, and we simply do a sudo SIFT install, and boom, it is now going to start installing the package on your Windows system. So all the tools and capabilities that you now have with SIFT actually can officially be installed on a Windows 10 Creators Edition and later system. So as long as it's 1604, which is the Creators Edition of Ubuntu on the Windows 10 workstation, you're going to be able to drop to a bash prompt from a command line. And I'll give a couple of demos here in just a few minutes as well to be able to demonstrate this so you could actually see, yeah, it does function. It still takes, for the entire installation of all the tool sets, it takes a little bit of time after you type the SIFT install script, but officially it does work. The only thing that you really aren't able to do, which we'll demo here in the getting started slides, is it really has a challenge doing the mounting of disk images. The Fuse driver and some of the other drivers don't work properly under Windows. So as long as you have FTK Imager, or you have another mounting capability that's a Windows tool on your system, as long as you get access to the raw artifacts from memory, registry, and whatnot, all the other SIFT tool sets will work properly. So as I mentioned before, the SIFT Workstation is chock full of hundreds and hundreds of tools that are on there. The entire list of tools is on our website. We have SIFT Read the Docs. And what we're able to do with that is we're still, keeping up to date with all the latest tools and capabilities. But, for example, we have registry examination tools. We have a lot of Python scripts that are in here. We have Foremost, Autopsy, Sleuthkit, Recall, Volatility, Book Extractor. I could sit there and just list all the tools and capabilities that are involved. And that's one of the reasons why we have some cheat sheets that are available to you that you could take a look at for at least getting started along the process. So what I'm going to do is switch over to my the back end of my SIFT Workstation here, and on my desktop itself, you will see. Let me see if I could get this. Actually, I probably should just reboot this real quick. get a clean desktop. There, restart guest. And what I'm going to mention here is that, in particular, the tool sets on your cheat sheet will at least get you started for some of the basic functionality, what your SIFT workstation is able to accomplish with you. And that basically walks you through some of the ways to do mounting and other options that you potentially find, in particular, when you're using the SIFT workstation. Which brings us to, we do have a plethora of cheat sheets that are also available on your desktop when you initially log in the system. One of them is the Windows Artifact Analysis cheat sheets that you see here. And on this cheat sheet, for example, it talks about different artifacts, what you potentially look for, what you're going to potentially be analyzing with that. The one thing that's missing here is like a recommended SIFT tool to do that, and we're actually thinking of migrating this artifact analysis chart over to talk about recommended SIFT workstation capability to be able to extract out that in particular data. Right now, it's kind of a generic, can use any tool, but I actually think I'd like to do a special version of the artifact analysis chart just to be able to show people how you can actually use the SIFT workstation to extract out the majority of these artifacts. For example, the AM cache hive, where this stuff is actually going to be sitting. But that's really not what this session's about, which is really like how do you essentially get started with this. So the first thing I'm going to do is demonstrate how do you copy evidence over to the SIFT workstation in particular. So I'm going to go back over to my SIFT workstation and log in. And the username password is Sans Forensics and simply the password forensics. And once this is loaded, you're going to have nothing on it. There's going to be no forensic data, no evidence that you're going to be working with. So we want to be able to add data to this. And whether or not if you're installing this on a standard desktop or slave system for SIFT workstation, you can plug in your USB will show up and you could transfer data to the system. But since a lot of you are going to be using this from an aspect of using it in conjunction with a virtual machine, the easiest way to get data transferred over to it is by pulling the IP address, and we already have some default SMB shares set up for you. So we basically copy the IP address, and we are going to go over to our Windows system in this case, and I'm going to basically type in that IP address that I just saw, which is 192.168.109.167. Press return, and it's going to ask me for my network credentials. And this network credentials is essentially Sans Forensics, and the password is forensics. And once you press return, you're going to see two shares. The M&T share, so in case you have any Windows tools you want to be able to, examine the different mounts that we're going to be working off of, you could use Windows and SIFT at the same time. But the main directory you'll be copying your data over to is the cases folder. So assuming that we have a cases folder here with evidence, all you would have to do is from your host system is I have a cases folder here. Say, for example, I want to copy over a folder such as the 2 CSV files I'd like to examine here. I want to copy over that folder to the SIFT workstation. Going back to that same directory location, I simply could put paste, and it'll copy over those files to the SIFT workstation. Now, what does that get you on the SIFT workstation side? You go into the cases folder here, and there's your evidence. And so because of the interoperability of basically using SMB mounts, you could easily copy files to and from the SIFT workstation, even if it's on your network. The other thing, since you're basically working off of a virtual machine here, you can always drag and drop files to and from the virtual machine just like it's a separate window. That's also an option as well, or just simply copying and pasting the files and data to the overall system. So that's the first thing that you'd be able to do, is copying files to the SIFT workstation. Again, the main way to do that is by simply looking up the IP address, using your Windows system, mapping that to a network share, using whack at the IP address. Using the username Sans Forensics and the password forensics, it'll give you the right access to the cases folder, and you could just copy over your data into that location. So right now, what I have copied over here is a EO1 file, which is a hard drive, and I also have some memory images in here as well that we potentially be able to work with when we're potentially working with the SIFT workstation. So the second thing we're going to demonstrate is, now that we have data copied over to it, how will we mount our disk images? How will we get access to the underlying file system via the SIFT Workstation. So again, going back to our SIFT Workstation, I'll do a clear to make sure I don't lose anyone where we're at here. So I need to go into the directory that contains my evidence files. In this case, my EO1 file that I want to have mounted as a file system is currently sitting here. So I first need to elevate my privileges to a root user by using sudo su. And once I'm here, I would simply use a command, or there's a couple options in here to do this. The first is ewf mount, which is going to take that EO1 file, and we're going to basically mount it at a folder called ewf mount. What that will do is extract out of the EO1 file to a raw image, and basically doesn't really extract out, it basically converts the EO1 file compressed evidence in, so you can actually see the raw image. So once I do that, I cd into my mount ewf mount folder. I will now see a single file in there called ewf1. This file is your raw evidence. That is your naked file system, in this case NTFS file system. In fact, if I do a file against it, it's going to tell me it's a NTFS file system. It shows it right there. So once you're here, you could do the full mount option, the mount -o, read-only options. But one of the things we have set up for you here is an alias to reduce typing. This is the mount option that we typically see. Read-only loop, show sys file, streams interface equals Windows. That will expose all the backend $sign files. So I simply do mount win against my ewf1 file. And what this is going to do now is I'm going to mount it at mount Windows mount. Now these default mount points that you see in here are again tied directly to the SIFT Workstation. We automatically create them for you so you get used to mounting them at similar locations, ewf_mount, Windows_mount, and so forth. So when I do the mount option that we now have access to in here, in the mount Windows mount folder, and I do an ls, I can now see all the files and folders from that raw file system. And also notice that this gives me access to the files that are generally hidden by normal Windows system mounts. So again, that's one of the ways that you could do a simple mount option. So basically two stages to extract out the EO1 and then do the mount win option. Now what I'm about to show you is a cheat method. Everyone likes to cheat, but I'm going to go ahead and expose this one to you because it's really cool to be able to see this one. So I'm going to basically go through and unmount the evidence that I currently have in there by using the command umount, and do the same thing against umount against my ewf mount folder. So I basically am back down to nothing. Nothing is mounted at this point, and I'm going to go back to my cases Windows 7 interim one-off C drive folder. So the way you could cheat is there's a tool called imagemounter.py. Now this Python script is able to do some things that will make your life a lot easier for you. It'll automatically mount an EO1 file to the folder that you want it to go to. It'll also automatically detect physical disk images, and if that physical disk image has an MS-DOS partition type or a GPT partition type, it'll automatically mount all the partitions that it finds in the subsequent mount locations. In this example, the EO1 file that we have is a partition file system. So I'm simply going to type imagemounter.py -s. I'm going to give it my image I want to have it mounted to, and I simply tell it where I want to mount to. In this case, is mount Windows mount. I press return, and it automatically does the two-step mount process for me. Notice it does mount under mount EWF, and it gives a date and time for the EWF1, and then it automatically does the subsequent mount at mount Windows mount. And we go into mount Windows mount, and there's all our files and folders one more time. If you do end up having a BitLocker encrypted partition, notice it does have the option here to take a recovery key. So if you wanted to mount a BitLocker disk, something that's encrypted using BDE, then you also have that option in there as well. There's also a secondary tool called BDE mount, which also allows you to take a password or recovery file to be able to unlock a BitLocker drive, a disk encryption volume. So that's another tool you could potentially use within the SIFT to manipulate the BitLocker disk encryption capabilities. And again, trying to throw you a couple options in here because typically people get to this point and says, oh no, my system has a BitLocker on it, what do I do? And generally the first question is, do you have the recovery key? And if you don't have the recovery key, then you have to use something like passware or something else to be able to extract and try to brute force it. Or hopefully you do have it, and then you're able to potentially use the recovery key to unlock and be able to mount the files and folders that are underneath. Now, the final thing I'll show you in here is going back to our mount. Remember I mentioned in the mount directory, and I'm going to remember my credentials this time, so I don't have to type it in every single time. So we go into SANS forensics. Actually, this time I'll type root. Actually, no, we'll just use SANS forensics, and forensics. Oh, access is denied. Let's try it one more time. More choices. All right, it's not allowing me into the mount directory right now for some odd reason. I have to figure that one out. Probably putting the wrong credentials in here. Does not like that. All right, we'll have to go back in there and take a look at that. But typically under the mount directory, I'd be able to go in there and see all the different mount points and see it directly from my Windows systems as well. Since I'm in the middle of live webcast, obviously I did something wrong here when I was setting up my demonstration for this example here. So that sucks. All right, so now that we have everything mounted and ready to go, and I go back to this location, I can see all my files and folders, what else do I have capability in examining? So going back to my presentation, that's how you mount disk images. So the next thing is, well, within these disk images, they're obviously potentially chock full of volume shadow copies. Now, on Windows, volume shadows are enabled generally by default. It basically is an entire backup of the logical partition on a Windows system. So you might typically on a standard workstation have probably a volume shadow snapshot exists once per week. It generally is snapshotted when you're installing new tools, new software, new capabilities. If major hardware changes occur, you could initiate your own volume snapshot. On servers, you're typically seeing volume shadow snapshots occur on a daily basis for backups. And also VSCs are routinely tied into how server side of Microsoft products are doing their internal backups. So being able to examine volume shadows via the SIFT workstation ends up being also extremely useful for us to examine. So again, we have our current snapshot here within our SIFT. This is our, today, when we mounted it. But what if in this file system, we end up having snapshots that we want to be able to revert back to? So maybe a file that existed 2 weeks ago is wiped and deleted today, and you want to go back and recover that file. Another example is you have multiple hibernation files that are likely also going to be snapshotted into the volume shadow. So you'd be able to use the SIFT workstation to be able to go back and grab out earlier iterations of the HyberFill. The HyberFill is going to contain a compressed memory image that you're able to extract out and see what was running on the system at the time the snapshot or the last hibernation file was created. And I have to be careful with using hibernation snapshot, but it's again when the last time HyberFill.sys was created. So in order to be able to examine this, we have to go back to our overall C drive directory, and I see our EO1 file in here, and I'm simply going to do EWF mount of our Windows 7 EO1 file and mount this again under mount EWF mount folder. And when I go into that mount folder, I'm going to simply see the in this case, a 25 gigabyte partition, which is what is encapsulated as my C drive. So I want to see how many volume shadow snapshots exist inside that NTFS partition. So I'd use a tool written by Joachim Metz using the libvshadow libraries, and he has a couple tools in there. It's simply called vshadow. And there's two tools in there. There's vshadow info and vshadow mount. What vshadow info is going to do, if I point it at the EWF1 file, it's going to show me all the different snapshots that are available inside that in particular partition. In this case, in addition to this today's file system, there are 4 earlier snapshots that we are able to identify and see. Notice that they're backed up on a weekly basis where these are found: March 15th, 23rd, 31st, and April 4th, where these snapshots are going to be found. So in order for us to mount these, we had to create a couple of empty hangers within our SIFT workstation. The first is, when you do an LS here, we see a directory called Mount VSS. This is initially where we're going to mount all of our volume shadow snapshot raw images to. The second one that we see in here is a directory called Mount Shadow Mount. And if I cd into the Shadow Mount directory and I do an ls, notice underneath here there is at least 20 or about 30 different volume shadow snapshot folders. Now these are essentially empty at this point. When I do an ls, there's nothing in there. But the reason why these hangers exist is when you have something that you want to mount there, it already exists, so you don't have to go back and create all of these locations when you're going through the process which I'm about to describe. So initially showing you, hey, there's directories are already set up for you to accomplish everything I'm about to do. On a normal system, it won't work this way, but we had to create it this way to make it a little bit more user-friendly on the back end. So step one is we're going to go into our EWF mount directory where we currently see our raw disk image that we just examined, 25 gigabyte. So we do vshadow mount this time, and I'm going to point out the EWF1 file, and I'm going to basically mount it at Mount VSS. What this does is it takes all of those snapshots and basically lets us view each of them as an independent partition. So when I cd into Mount VSS, when I do ls-la and press return, I am now able to see in here that there are 4 partitions, VSS 1, 2, 3, and 4, of different previous snapshots that are currently stored within that logical partition image that we're currently examining. Now here's where independently you could do a mount command for each one of these, where you do mount when VSS2 under Mount Shadow Mount VSS2. And essentially what this is going to do is take that partition and give me direct access to it at that equivalent location, which I now see all my files and folders from that earlier point in time. But what if you have a system that has like 20 or 30 different volume shadow snapshots that are available? Manually typing each one of these things in there is going to be, you know, a pretty brutal attempt to be able to get access to all these different locations. So one of the things you could do is using the prompt here to help you out. We're going to basically execute a for loop to automate the process of doing all these mounts. So the first thing I'm going to do is to demonstrate that, I'm going to umount my VSS2 partition and go back to my Mount VSS partition. Once I'm in here, again, you see the 4 partitions. So we'll do for I in VSS star semicolon do, and the command I'm going to type is mount when, and it's going to be $I, so it's going to be mount when VSS1, then VSS2, then VSS3, then VSS4, and I'm going to mount shadow mount $I, find $I, and that's going to basically mount VSS1 at VSS1, VSS2 at VSS2, VSS3 at VSS3, and so forth, and semicolon done. And so this is basically going to create a loop for us to automatically mount all of our volume shadow snapshots into volume mount of shadow 1, VSS1, VSS2, VSS3, VSS4. And you notice over here, it kind of flashed all the different file systems that were popped up. We do get an error here, and one of the reasons we get an error is one of these snapshots in particular ends up being corrupted. So we actually can't mount it, but if we could identify which ones were able to be mounted successfully by going into the shadow mount directory and doing an ls-la, and you notice in here the ones that are now colorized in green are where we have file systems currently mounted. So VSS2, VSS3, and VSS4 are currently mounted, so we have direct access into these folders directly at this point. So if I go into CD into VSS2 and do an ls, I'd be able to see files and folders in here. Same thing with VSS3, and these are from the different snapshots that we're able to see. And if you wanted to really, you know, peel these apart, you'll be able to notice that you know, the files are changing, the modification dates change, the registry hives that are embedded in each one of these are completely different, you know, from that point in time. And that's one of the reasons why you need to go back to your when were these snapshots created, is that vshadow info command which we ran against the original EWF1 file, which tells us for each one of the partitions, store 1, 2, 3, and 4, when that snapshot occurred. So if you had a file that existed on March 24th, then you probably need to go to the March 31st snapshot and before to be able to see if you could still go back and recover that file in particular. So this at least gets us access in there to be able to use the SIFT Workstation to gain access to a variety of volume shadow mounts within the Windows NTFS partitions that we now have access to. So it does make life a little bit easier for us when we do this. So that is your basic, how do you copy files over to the SIFT, how do you mount just the raw disk image in NTFS, and then also how do you mount NTFS volume shadow copy snapshots. So you could potentially go in there and do registry examinations or do anything else that you might want to go take a look at, which will now get into some analysis techniques that are potentially available to us. So one of the biggest things that you'll see a lot of individuals want to try and accomplish is to create a timeline via the SIFT Workstation. The timeline creation capability is built upon a set of tools called Plazo. And Plazo basically is created by the Google Instant Response team, initially started by Kristen Gujanson's SANS GCFA gold paper project back in 2009 called Log the Timeline. And that project in particular has really taken off in the Google Instant Response team with Wacom Metz and a bunch of others are currently keeping up to date with the latest version of Plazo, which includes a Python script called Log the Timeline. And so the way this works is we go into our, in this case, we can essentially go into EWF mount directory where we're currently at 2. Since we're already in here, we'll go ahead and demonstrate this. Mount directory, do an ls, there's the EWF1 file. So all you need to do is simply type logthetimeline.py, and our cases is our output file where we want to dump this to. And we'll simply call this plazo.dump. And we're going to simply target the EWF1 file. Now, this simple command that we're currently executing here is going to automatically identify not only the existing partitions, but all of the partitions that are in there. And it's going to attempt to run every single plugin that Log the Timeline has capability of being able to extract automatically. And one of the first things it does is take a look here. It automatically ties into the fact that we have 4 volume shadow snapshot stores. Log the Timeline does ask the question, do you want to parse more than one store? And you could obviously down here say, yeah, I do. I want to go store 2 ... through 4, which includes the current one, and I press return. And this is going to essentially start the processing extraction into the plazo.dump file to be able to create your initial basic timeline. Now, I say basic, but this is going to be the kitchen sink approach to timeline analysis. It's going to try and analyze every single artifact that is inside the SIFT Workstation that is running at this point. The number of workers is actually tied to the number of processors that you have slaved over to the system at this point. We have 2. And number of CPUs that we have involved. And if you have this installed on a desktop system, you could really improve the performance of Plazo and Log the Timeline by being able to slave over a lot more processors than what we're able to do within virtualization, which makes life a lot easier. Now I'm going to pause this right now, but it gets the point across that being able to create a simple timeline by using Log the Timeline is a very effective mechanism. We probably need to do a couple of follow-up, now that you have it created, how do you do the initial analysis for it? But typically you could do psort of that plazo.dump file into a CSV or Excel spreadsheet, or what a lot of more advanced users are now doing is automatically importing it into a ELK instance, a backend time sketch instance that you're able to then view the data that you have extracted directly. But again, with our short time here, again, this is just getting started with the SIFT. One of the key questions always says, how do I create my first timeline? That'll get you started, and then on the documentation pages and on the SIFT Workstation cheat sheets that are in there, it basically will step you through what are the next steps to be able to accomplish that as well. All right. What about memory analysis via the SIFT Workstation? Well, this, again, there's 2 tools that are installed in the SIFT that will help you out, recall and volatility. So you potentially be able to use both. One of the great things that we've been able to do with memory analysis on the SIFT Workstation is that there are a lot of third-party plugins for volatility in particular that we have incorporated into the overall framework when we're working with the tool set. So a lot of these third-party plugins automatically could be found within here. For example, a tool set called Baseline, which will do diffs against process baselining, in addition to driver baselining, be able to do diffs between a baseline system and the current system that's compromised, be able to see it. So Baseline is one of those third-party plugins that, again, we potentially try to integrate, make sure that they work, and make sure that overall general functionality is there. Now, one of the things I'd like to do here with this is, instead of just doing the simple, let me go back to my own virtual machine demonstration, I want to go back to the example I mentioned before, is that you can actually use the SIFT Workstation on Windows to accomplish a lot of this as well. So on my screen here, I'm simply going to drop to a bash prompt, and I'm going to go into a location on my system where I end up having the same data files, in this case my memory data files that I'm going to be working with here. And here's where I have a raw memory image, Win732 in Romanoff memory .001. So simply once I have SIFT installed on my Windows Ubuntu workstation, I can now do viola.py, point it at the against memory image. And once I get to this point location, I need to give it a profile. In this case, the profile is Windows 7 SP1 x86. And I could do PS list or any other plugins that are inside volatility that allow me to then basically crank through doing memory analysis. And this basically shows you that, oh, didn't type it correctly. Windows 7 would help if I tell which actually operating system it is. That's what happens when you happen to be typing on one of the cutoffs at the end of the page there. But basically, it does show you that the plugins in here will work. If you want to see which plugins are available, you could just do the -f info, and of course, it's going to crank through and list out all the different plugins that are available within volatility. Now in 508, we spend an entire day basically talking about really the greatest hits of memory analysis plugins for intrusion-related operations. But again, from the volatility version 2.6 or even recall latest versions, the basic functionality is in here, all across the board. So you could use recall, you could do volatility. It's all going to function the same way when we end up using it. So the main idea here is that memory analysis be the SIFT either on your Ubuntu side or under, well, it's still Ubuntu on Windows, but either if you install it on Windows and you wanted to crank through the artifact analysis, you'd be able to do so through that mechanisms. Another one that always comes up here is doing registry examinations and be able to be able to extract a lot of data out of, be able to do basic examinations via the registry. One of the, I'm going to give you a couple examples in here of how we do this. But one of the ways that we're accomplishing this is using Redripper, written by the amazing Harlan Carvey, who's been keeping up to date with all the different plugins and a lot of third-party plugins that are in there. But one of the things that you notice with Redripper is that trying to keep all the plugins up to date is hard, and we've actually spent some time coding to ensure that if you do a SIFT update, it's going to download the latest versions of all the plugins, and then any new plugins or any additional plugins, it'll rewrite your overall configuration files into user, system, SAM with the additional plugin names. So you don't have to, when you're using rip.pl to be able to do the extraction, you don't really need to worry about whether or not your configuration files are now set. It's totally automatically taken care of for you, unless you're doing a direct call out of a single plugin using Redripper framework. Another couple of third-party plugins, which I'll also mention here, is Shimcache Parser, which again will allow you to extract out the Shimcache, AppCompat cache entries from a system registry hive, get a good evidence of execution examination there. So going back over to our registry hive files, and we'll go ahead and take a look at a couple of them in here. Going to Mount, Windows Mount. Let's do a clear, and I'm going to go to my users. We'll go in Romanoff, and in here we end up seeing the in Romanoff's into user.dat hive file. And you say, okay, I want to be able to extract out the content of that HI file, so I could examine the contents of it for forensics purposes. So if you do rip.pl, it's basically going to tell you how to use the command line interface to the Regripper toolset. But if I do rip.pl-r and I point at my anti-user.hi file and I do -f nt-user, is basically say what's the plugin file that I want to run. This is going to run all the different Perl scripts that Harlan and his team have configured on his GitHub site. It'll automatically run them all against the anti-user.hi file. But you could also use a very directed. You could only use against a single plugin file. But in this case, I'm going to say, okay, run it against everything. We press less, and it's going to start cranking through all of these. And you basically start scrolling down, and you have all the different outputs for any of the different output, plugins that are run. Now, for each one of these, a couple examples in here. You have WinRAR is one of the plugins, and this directory is not, or this registry Hive key location is not found, so it moves on to the next one. But if it does find one in here in particular, it's going to be able to extract it. Really easy to do. Another example of that is I go into the Windows System 32 config directory. I use rip.pl. Again, there are paths anywhere, so you could run it from any location. -f SAM is going to extract the data out of the user registry Hive files as a security accounts manager. And we basically are able to see user information, the administrator, user content, when the account was created, last login dates, reset dates, and so forth. But this is kind of examples of what Regripper is able to do for you. The hardest part of Regripper I've found, talking to people over the years, is basically trying to keep up a really good copy of it locally on your system. And that's now taken care of for you through the rip.pl interface. Harlan has a really nice GUI and package that you could also download on Windows 2 that I highly take a look at and examine. But again, this is just a quick how do you get started? Here's how the basic tool works after you have everything mounted. And the cool thing about the Regripper interface here is to be able to move quickly and to be able to do the extraction of the data. One of the other ones that people always ask is about what about shimcache data? Now there's a couple third-party, actually I think it's big S, shimcacheparser.py. When we do -h, and here what this is going to do for you is basically extract out the data of our system Hive file to be able to show any executables that have been run on the system or initially touched the system or potentially run on the system that are new. And the shimcache is a really good resource for potentially identifying malware. So in this case here, we're going to do shimcache.py I for Hive file. In this case, we pointed the system Hive file. And we are going to set an output file, or we'll set to default to standard out. --BOM is a necessary option for being able to import into our CSV files. And you press return in here, and it basically, you could output this to a file, but it's going to list the last modification time of the file and the executable name. A lot of people get this one confused because this is, a timestamp. You initially think, hey, this is the actual time of execution. It's not. It's the modification time of the file. But we're able to see in here that it effectively extracts out all the data from the shimcache, which again is sitting in the system registry Hive file. There's a little other not well-known point in here that really helps out when you're doing the examination, is that the order in which these artifacts are currently sitting in this output are actually in temporal order. So you can actually use this to kind of guide you on when things happened, but not be able to detail the exact time of when things happened. But it gives you a couple examples in here that, in addition to Regripper, we do have a bunch of third-party utilities that we have all downloaded into the user local bin directory, that you'll see a bunch of them in here, Python scripts, Perl scripts, and more that you can read through in here that we're trying to manage and keep these up to date from the various GitHub sites that we're pulling them from. IDX parser, job parser is a really good one in here. There's a couple different variations of that, jobparser.py, jobparse.pl, and more that we're able to see that essentially be able to extract out .job files and more. But you get kind of an idea of what a lot of these capabilities you'll be able to accomplish and examine in here. In addition to that, you also have capabilities like the sleuth kit, where you could use BCAT, DCAT, be able to go back into the ISTAT, running FLS to create a very basic timeline and more through the overall iteration of the SIFT Workstation. So That's how we do registry examinations. So, you know, there's so much to the SIFT workstation, you know, and again, only trying to get started here. And this is really just how do you get started? You know, downloading it, installing it, mounting disk images, and going from there. But we have put together a variety of really decent cheat sheets. Some of them are sitting on your workstation already. We have a overall SIFT workstation cheat sheet that's here. When you fire this open, it's going to, you know, show you a lot of the basic commands that we just went through. That allow you to, you know, get it like, how do I do that again? You know, like the red dripper and so forth commands. We also have a volatility cheat sheet in here as well as a recall one that you could take a look at. And here's the sleuthkit tools. Here's how you create shadow timelines, memory analysis stuff, creating super timelines, mounting DD images, recovering deleted registry keys, and more. But some basic stuff you could do with the SIFT workstation on these cheat sheets. Another cheat sheet that is very useful to you is a poster that we created that has cheat sheets for both the SIFT workstation and Remnix on it, and you could take a look and download this, you know, again, for a lot of the how-to commands once you get things up and running of how to potentially work with this on the back-end side. When we're going to be, you know, again, you know, we spend an entire class, you know, across 572 network forensics, 508, our intrusion forensics class, memory forensics on 526 uses the SIFT workstation. 578, our cyber threat intelligence course uses the SIFT workstation for using sticks. Sticks is installed on here. So there's a lot of, we actually need a full course just on the SIFT workstation, to be quite honest, of, you know, everything that we're now piling into the workstation overall. So what I want to do is hand it back over to our moderator, and hopefully I'll be able to answer questions for the next 10 minutes until we're able to close off. A couple notes before I note here that our two brand new coins are for our two courses I author, 500 and 508. We have two new coins that are out there for those who win the challenges, so take a look at those. Really proud to have those also released in the past few months. All right, Carol.
Thanks, Rob. We have a bunch of questions for you, so I'm going to dive right in. Some of these came a while ago, and perhaps you've answered them on the way, but what is the best way to update an older SIFT?
It's really hard. What I actually do recommend at this point is starting with a clean 1604 version and doing an update. Now, the reason why I say that is now that we have the SIFT, the salt stack stable, once you're on a salt stack install and being able to update it, it'll be a lot more cleaner, so we can actually do an upgrade it'll download the latest CLI and automatically update itself. But for anything that's older than that uses the old bootstrap, generally we're recommending starting fresh at this point, just because it's, you know, we had to completely shift over to a new framework for doing the updates and installations. If you're already installed via salt stack method, then the CLI should automatically be on the system. All you have to do is SIFT update, SIFT upgrade, and it'll update itself at that point. It's just a single command line. And if you just type SIFT with no options, it'll give you all the options in there that are available to you. So, you know, for example, going over to our own SIFT here, just type SIFT, and it should give you the update upgrade capabilities that are in here. So you can also see list upgrades, you know, very useful kind of tool and framework that we're going to be able to have available to you. Good question.
All right, thanks. Please retype the location of the cheat sheets to the chat window. Is that on one of the slides?
Yeah, the cheat sheets is located on this slide that's right here, digitalforensics.sans.org/community/cheat sheets.
All right, maybe if we could leave that pulled up for a moment, that'd be great.
Will do.
How do you recommend creating the forensic image?
How do I recommend creating a forensic image? Well, depends. Typically, if you're on a live system, FTK Imager is a really good option. Allows you to export in both raw .img format as well as EO1. Most of the capabilities out there, whether in case, FTK, even X-Ways, have their own acquisition capabilities. Same thing for memory. Since we're talking about acquisition, there's a lot of memory acquisition capabilities. Magnet Forensics has a memory acquisition. You have Kome's dump it utility. And of course, my favorite to use for acquisition for both memory and disks is fresponse, and just using DD via the SIFT workstation.
All right, thanks. These two, I'm not sure if they're related. Someone says the URL shown in the beginning doesn't seem to work, and then somebody said typo BitLocker. I'm not sure what they're referencing there.
Okay, let's go back here. I may have copied and pasted that in, but didn't actually type it. So this one is not working. I'll double check that that's working. If not, then you go out to this dfir.sans.org, just go under SIFT Workstation as the menu drop down. It'll take you to the same location. But that should work. I'll double check it.
All right, thanks, Rob. Does it support other encryption methods to recover the keys? Is it by any chance asking us to insert the key, or it just recovers it for us if the key is unknown?
I assume they're talking about, like, other encryption, disk encryption formats. Typically, a lot of the utilities that like Symantec and a bunch of others have for their enterprise-wide disk encryption utilities, they actually have a version that works on Unix. We don't have the ability to distribute those, but typically they do work on Ubuntu. There's usually an Ubuntu version that'll allow it to unlock a disk. It's just a matter of going to their support, even asking the question, hey, do you have an Ubuntu version of your product that I could use? And basically you'll copy it over and it should work. But since most of this stuff is licensed and proprietary, we can't really distribute it easily on here without getting permission.
All right, thanks. Would it be possible to get the image files that you're using in the demo?
That's a great question. If you email me separately, arlie@sans.org, I'll see if I could give you a couple example demos. This is actually one that we use in 508. And I have to go to SANS and see if I'm allowed to release those or not.
Thanks. First of all, they want to say it's an excellent presentation. Second, are the artifacts collected by SIFT admissible at courts of law in the US and EU, considering that we are talking about open source?
That's a very good question. I almost said one that deserves its own publication on, but yeah, open source products are used all the time for being able to examine evidence and be able to use it in a courtroom. The key principles are that there's nothing that is not admissible from the open source community. It's kind of like saying that when you're doing crime scene photography, you're only able to use Nikons and not Canons. There's nothing that's a court-approved tool. Typically, you'll see certain law enforcement units say we're only allowed to use FTK, but that's mainly because they have 400 agents and everyone uses a different tool. Bad things might happen. But, for example, I know David Cowan and Obi Carroll and a bunch of others that are frequently in the courtroom. A lot of them write their own tools. And as long as it's repeatable, reproducible, and you're able to show exactly what the artifact is, and even using a third-party utility to be able to get to the same output, it is a completely viable option. And again, that's a short answer, is that there's nothing as a court-approved tool. The thing is that if you write your own scripts, it is still perfectly allowable. You just have to be able to, show that you went through the, that you understand what the tool's doing, that how it's extracting the data. And in many cases, the commercial utilities that are out there that do something similar don't even parse the artifact you might be doing. So you might need to write your own Python script or Perl script to be able to accomplish it. And that's one of the reasons why there's such a robust community of open source tools that are out there, because we can't simply rely on the commercial vendors to be the only location to be able to parse certain aspects of evidence.
All right, thank you. Can you do something that shows USB usage?
Yeah, USB usage, if you actually go back to our slide here on the Windows Artifact Evidence of slide, we actually have an entire column here on external device and USB usage that talks about different registry keys and different artifacts and different log files that you could use Regripper. You could simply cat the setup API dev.log file, look at the event logs using the different event viewers that are on the SIFT to be able to extract out potential USB usage. Really good case example there that you're highlighting, that in conjunction with the poster we're highlighting and tool sets within the SIFT, using that to narrow down to that exact location will help you do it. And again, we do this in 500 and 508 in particular for these types of cases. But again, and it's just really how do you get started in here? The easiest answer right now is this is going to give you a list of artifacts you could look at, and then you could use a SIFT Workstation cheat sheet to be able to say, does the tool spit out the artifact location to me? Usually Regripper gathers most of these that we're going to be looking at in here.
All right, thanks. Does Remnux work with the new SIFT? And then someone asked, this might be a question. Oh, go ahead.
Yeah, we're currently working on the latest update with Lenny to 1604 version. So it will be able to work side by side. Getting both of these things to release identically at the same time has been a challenge. But just like one of the reasons why it took us a long time to switch over to 1604 for SIFT is that we had to rewrite our installation scripts, which currently Lenny's Remnix is a bootstrap script, but Eric Christensen is working with Lenny right now on converting his bootstrap to a salt stack install. So you'll be able to do a Remnix install just like SIFT install, and you potentially have both flying side by side. We have been very we like the idea of both of these things functioning at the same time. So it's coming, and we definitely want it to get there. And it's just a matter of finalizing and testing that salt stack install. But we're getting there.
Hey Rob, we have a bunch more questions. We're at the top of the hour. I can keep going if you can.
Yeah, I'm good to stay if people want to hang on and see if their question will be answered.
Okay, great. Let's see. Additionally, the VSS folders, can we create more or archive the existing content after the case is finished? How does it work? Every time we mount, it creates a new set of VSS folders?
Well, the VSS folders already exist. When we do the mount, it's going to basically open up the contents of that file system onto the folder structure. Typically, one of the reasons I'm a big fan of virtualization and forensics is that at the end of a case, you could freeze all of your data by simply pressing pause or archiving your entire virtual system. We actually have two hard drives in the SIFT Workstation itself. One is just a cases folder, and the other is your root directory. That way you could actually extract just the VMDK that contains all of your evidence data into a separate data storage location or cloud location. But I like the idea of virtualization just from a, well, what if 3 years from now someone asks you, how did you get that data? Can you validate it? But all the tools have obviously progressed for 3 years. You need to make sure you're showing the version that you used 3 years ago. Thus, virtualization comes into play. If you paused it, archived the VM with the original data, you could fire it back up, run the same tool, show you how you got the same data. But your question on the, does the virtualization VSS stay there? Well, once it's mounted, if you reboot the system, you're going to have to remount it. It's mounting it in read-only mode, so nothing will change. Your MD5s will stay the same. You're just using the SIFT Workstation to get direct access into the backend of Volume Shadow Snapshot folders.
All right, thanks. What's the primary difference between the SIFT install I can pull down from SANS and the one I received from 508? And another person asks, is the version of SIFT VM on the SANS site the current release you demoed?
Yes, the one that's on the website is the current release, with one exception, which is the desktop background. I just changed that to our current logo. In the probably next version that we're having the OVA, we're going to switch over to those new desktop logo. But yeah, that OVA is the one I just did the demo on, with the exception of the desktop background change. What about the one that we distribute in classes? We have a community edition. That's the one that we have on our website. Each class version from 572, 526, 508, 578 might have a fork, a slight variation of a fork. I also turn off updates on the 508 version because people simply doesn't update. Well, that could kill all the exercises in the class if one tool changes a TAC option somehow. So we really try to make sure it's stable. It's not going to upgrade itself. And in 508 and several other classes case, we actually have a couple commercial utilities that we are allowed to distribute only in the classroom version of the SIFT. So you get a license of it, for like 90 to 6 months. TZ Works is a good example. So the classroom versions are a slight variation fork, but they're all based off of the same 1604 community edition. It's just a slight variation that we have to work with to be able to freeze it, make sure it's stable, and in some cases we have licensed tools on it.
All right, thanks, Rob. For the next two, I assigned them to you so you could see them in the chat window. If you could take a look, I'm not really sure the question of either one. Do you mind?
Okay, let me see. I will look at it.
Sure.
All right. Have to make it big. So, I always start desktop by first making a FTK image with the right blocker. Is not the best way to start. What is your suggestion on image capture? Well, if you are able to remove the hard drive, which is questionable today, I'm actually working on a Surface Book myself. If you can remove the hard drive, implementing a right blocker, that is the most forensically sound process, but it's also not feasible if you're doing remote forensics either. So either deployable agent, F-response, other deployable agents in your enterprise will also potentially allow you disk access, guidance as agents, and so forth. Most of them will also allow for remote disk partition or physical disk capture. The only downside of physical disk capture on a live system is if it's encrypted, you have to use a tool like to decrypt it before you're able to examine it. But in the instance that if you do a logical capture of a partition on a live host, and that is BitLocker encrypted, for example, the logical partition will be unencrypted of that what you image, which is a very easy way to do it. But if your basic standalone system, desktop, remove hard drive, right blocker, FTK imager is a perfect way, and then copy it over, or even mount it via the SIFT, plug it in USB. USB 3 works fine within SIFT Workstation interfaces. Second question is, when will upgrades show available? SIFT Workstation 2, password for Forensicator. No upgrades available. You might be at the latest update. I have to go back and check. If you could, I think this is Doug Metz. Doug, if you could send me a note, and I'll have Eric and I look at that separately because you're getting into actual troubleshooting on your own systems. And also, we do have an GitHub issues site. If you go to the SANS website and you click on the bugs and issues, you can actually open up an issue on the SIFT Workstation and say, hey, this isn't working. Can you take a look at it? But if the upgrade's not published yet, then we should be able to get that out here pretty quickly. But the current OVA does have is the current latest version. We just actually burned that last week for what we have. So if we don't have the upgrade out there yet, Eric and I will take a look at it and see if we can get that out pronto. Good question. Thank you.
All right, thanks. Looks like our last one is best way to upgrade to new SIFT. Should I copy files under SIFT Workstation cases to Windows system, install new SIFT, then copy back over files?
Actually, the best way to do it, and I'll switch over to my VM to show you this, is that the SIFT Workstation, we build it intentionally with the idea that you might be using two VMDKs. If you notice here, we have the root directory, which is 100 gigabyte VMDK, and then we have the hard disk is our cases directory. And this is this hard disk, the 500 gigabyte hard disk here, is you can add your VMDK from another system, add it over to the SIFT. That way you don't actually have to copy the data. It just becomes like plugging in a drive sled with your case data on it. Typically, if you're using another SIFT, which is built off of the same one, and you replace it, it actually will, because it's the same disk ID, it'll automatically mount. If you don't do that, then what you basically will have to do is go in there, manually mount that additional VMDK, which will now show up as a file system within your SIFT Workstation. I'm usually not a fan of copying the files over. Bad things can always happen, but once it's on a disk, just swap over the VMDK, add it to your system by simply edit virtual machine, add VMDK, and that will allow you to add the additional VMDK that contains your case data from an older version of the SIFT. It's a really good question.
All right, with current SIFT upgrade, why is, I think it's Plaso or Plaso log2 timeline.py version still 1.4 and not updated to current version of 1.5.1?
Great question. One of the reasons why is we have found that 1.4 is, based on our testing, is the most stable version. Once log to timeline, I think they release into, I think, 1.6, their cutting edge version has solved some key issues that we were finding in 1.51. And I'm not saying it doesn't work, but again, across the board, the general consensus is the most stable version right now is 1.4, even though some of the capabilities on 1.51 don't exist, which would be nice to have. We're currently looking at the next version once it's stable and it's released. as we'll probably update it at that point. Now, if you do want 151, you can actually manually update that via the GIFT repository, which is what is maintained by the Google response team. But that's one of the reasons why. It gets into a long, we're not saying that there are significant problems with it. We've just found enough issues have cropped up on how we're using it that we've held the release back intentionally. And we do that on occasion based off of feedback, instructors talking to the development teams and so forth. So yeah, that's the main reason why.
All right, well, that concludes our webcast. Thank you so much, Rob, for your great presentation, which helps bring this content to the SANS community. To our audience, we greatly appreciate you listening in. For a schedule of all upcoming and archived SANS webcasts, including this one, please visit sans.org/webcasts. Until next time, take care, and we hope to have you back again for the next SANS webcast.